Hey, Algebra 2B, here's another video for you. Today's lesson is 12.3, Arithmetic Sequences and Series. Now, we talked about these types of sequences in lesson 12.1, but we never really talked about them explicitly as being arithmetic sequence. What makes an arithmetic sequence? An arithmetic sequence is called arithmetic because its successive terms differ by the same number, d. So we're adding a value every single time. So when our first differences are a constant, we have an arithmetic sequence. And the example they have here in the textbook is the cost of mailing a letter in 2005, based on its weight in ounces, was the following: 37 cents, 60 cents, 83 cents, $1.06, and so on. Every ounce costs an additional 23 cents. So we're basically adding 23 every single time. Recall that linear functions have a constant first difference, and notice also when you graph ordered pairs n and a sub n of an arithmetic sequence, you would get points that would line up in a straight line. So you can think of arithmetic sequence as a linear situation with sequential natural numbers as the domain. So how do we know we have an arithmetic sequence? We have to look at the common differences. And that's really quite simple. To determine whether each sequence is arithmetic, you basically look at the differences. So if we have in example 1 here, A, we have -3, 2, 7, 12, 17. So we look at 2 minus -3, that's 5. 7 minus 2, that's 5. 12 minus 7, 5. 17 minus 12, also 5. So we're basically adding 5 every time. So the next term would probably be 17 plus 5, which would be 12. If we look at part B, though, we have -4, -12, -24, -40, -60. You see how those numbers are going up a little bit more quickly? It's a good clue that we probably do not have an arithmetic sequence. But if we look at the differences, -12 minus -4 is -8. -24 minus -12 is -12. -40 minus -24 is -16, and so on. I don't need to keep going because I know this is not arithmetic because the first differences are not the same. Now, if we look at the note packet, basically this is the summary of what we just discussed. To determine whether or not a sequence is an arithmetic sequence, you check for a common difference that we call D. So if you look here, they subtracted and they got 4 every time. So the common difference is 4. This sequence is arithmetic. But if you look at the other example here, they got 4, 12, 36, 18. There is no common difference there. So it's not an arithmetic sequence. That is some of what you're going to be asked to do today. The other thing you're going to be asked to do is to figure out what the explicit formula is. Now, if you know the first term of a sequence, A1, and you know the common difference, D, then you can find the nth term by using this rule right here. It is this. A sub n is A1 plus n minus 1 times D. Now, sometimes we rewrite that, and I think we even talked about this in lesson 12.1, as this, D times n minus 1. It's the same thing. When you're multiplying, it doesn't really matter which comes first, D or n minus 1. Anyway, to find the 15th term of this sequence, we got 10, 4, -2, -8, -14. We first have to find the common difference. Now, the big clue here is they've already said it was arithmetic, so we don't have to find all the differences to check. We can just assume it is. So you just take the first two, and that's what they did here. 4 minus 10, they get -6. So D is -6. The first term is that guy there, 10, so you just plug those in. And you're looking for the 15th term, so that's what n is. So basically, we got D is -6, A1 is 10, and n is 15. Plug all those in, do the math, you get the 15th term is -74. So let's do, looks looks like I already did these, so 1 second here. I'm just going to erase all of this so that we can do it together. Probably should check this before I make a video, but anyway, here we go. If we look at these guys here, what is the common differences? So 15 minus 3 is 12. 27 minus 15 is 12. 39 minus 27. Can't do that one off the top of my head. 39 minus 27. Hey, guess what? It's 12. I'm going to assume that's also 12. I'm going to say yes. And D equals 12. 9 minus 3 is 6. 27 minus 9 is 18. Don't really have to keep going, but 81 minus 27 is 54. And 243 minus 81 is 162. The answer here is no. It's not arithmetic. And the reason why we don't have a common difference. This one is actually we're multiplying by 3 every time, but we'll deal with that in another lesson. All right, let's look at this. 2 minus 10 is negative 8. Negative 6 minus 2 is negative 8. Negative 14 minus negative 8. Negative 8. The answer here is yes. And D is negative 8. All right, so here we want to find the 10th term. So here we have to first find D. So I'm just going to do 13 minus 5. That is 8, right? Yep. A1 is 5. That's my first term. And n is 10. So I'm going to say A sub 10 is 5 plus 10 minus 1 times 8. So 5 plus 9 times 8 is 77. So A sub 10 is 77. Here, let's see, 4 minus 7 is negative 3. Sometimes your difference can be negative. My first term is 7. And I'm, again, looking for that 10th term. So I'm going to say A sub 10 equals 7 plus 10 minus 1 times negative 3. Now, the reason n is 10 is because they asked you for that 10th term. If they ask you for the 15th term, n is going to be 15. If they ask you for the 100th term, n is going to be 100. Just realize that that's going to change depending upon the problem. So let's see, here we have A10 is going to be 7 plus 9 times negative 3. 9 times negative 3 is negative 27 plus 7 is going to give us negative 20. So really pretty simple stuff, I think. All right, let's go back to the text here. If we scroll down a bit, they show you how to derive that formula we talked about and how to apply it in example number 2. And they even show you how you can graph these on your calculator. If you do that, if you plug this into your calculator just like that, you can find lots of terms just by scrolling through a table. You can find the 10th term real easy. How do we find missing terms? All right, so how do we find the missing terms here? We have 11 blank blank negative 17. All right, so first of all, we're going to find the common difference. What I'm going to do here is I'm going to say, okay, A1 is my first term. Negative 17 is my 5th term. So what I'm going to say is negative 17 is equal to 11 plus 5 minus 1 times D. D is negative 7. So then I can use that formula to find all the terms in between. Basically, I'm going to add -7. So you're going to get 4, and then -3, and then -10. So not that tough. If you look at the note sheet, there's even a little bit more complicated version of this. If you know any two terms in an arithmetic sequence, any two, you can find the first term. You know, any two terms, you can find any other term. First, you're going to have to find the common difference. Then you're going to use the formula for the nth term to find the first term. And finally, the nth term. So we're actually it's a three-step process. So step 1 is find that difference. Step 2 is find the first term. And then step 3 is use what we have to find the nth term. So if you look at this example here, step 1, find the 12th term of with A3 is 33 and A9 is 117. So this one, there's like 6 in between them. All right, so to find the difference first, I'm going to say instead of an equals a1 plus n minus 1 times d, remember that formula, it's going to keep coming up again and again and again all throughout the lesson. I'm going to use this. I'm going to say, okay, a9 is a3 plus 9 minus 3 times d. So 9 minus 3 is obviously 6. Plug in 117, plug in 33. Solve for d. So basically you're going to subtract 33 minus 33, and then you're going to divide by 6, and we get d is 14. All right, so once we know that common difference is 14, I could technically just keep adding until I get to 12, but might be easier to, again, use the formula. So then I'm going to use the formula again. Same guy. This time I'm going to say, all right, A3, whoops. This time I'm going to say A3 is A1 plus 3 minus 1 times 14, because I'm looking for that first term, and I know my difference is d. So that's 2 times 14, 28. All you got to do is subtract 28, and I get A1 is 5. So now that I know that, I can plug that in, all the knowledge I have. I know A1, I know D, I know I'm looking for the 12th term. Plug them all in. 5 plus 12 minus 1 times 14. Do the math. You get 159. So let's take a look at 6, 7, and 8. They're basically one problem. We're going to look for that 10th term, just like we did on the first page. A4 is 34 and A6 is 52. All right, so step 1, let's find D. So I'm going to say AN is going to be A sub 6, A1 is going to be A sub 4, so I'm going to say A6 equals A4 plus 6 minus 4 times D. So basically 52 equals 34 plus 6 minus 4, 2D. So I'll subtract 34, I get 18 equals 2D, divide by 2, D is 9. All right, so now that I know D is 9, I also know that A4 is 32, so now I'm going to go and I'm going to let AN be A4 and say A4 equals A1 plus 4 minus 1 times D, which is 9. So I'm going to say 34 equals A1 plus 3 times 9, or 34 is A1 plus 27. So I'm going to subtract. I get 34 minus 27 is 7. So A1 equals 7. So now that I know both of those, I go back here and I'm going to find n. This time n is 10 because I'm looking for the 10th term, so I'm going to say A10 equals a1 plus 10 minus 1 times d. So a10 is 7 plus 9 times 9, because d was 9. So a10 is 81 is 9 times 9 plus 7 gives us 88. So it's a three-step process. Step 1, find D. Step 2, find A1. Step 3, use both of those to find whatever term you're looking for. All right, let's go back to the text and let's talk about, there's another example here. Example 4 kind of goes over that. And really example 3 is kind of a variation on that, except we're only looking for D, and then we're going to use D to find those terms that are in between. All right, so what they don't talk about on the note packet is an arithmetic series. And if you remember, a series is actually a sum of the terms in a sequence. So what you get, if you have an arithmetic series, you can derive what we call a general formula, S sub n, for an arithmetic series. So basically, the sum of the first n terms, however many there are, like we were working with a sub 10, so 10 terms. It's the product of the number of terms and the average of the first and the last term together. So what we get is this. You don't have to worry about this math here, just worry about the end result. S sub n equals n times a1 plus an divided by 2. So if I want to find the sum of the terms in arithmetic series, all I need to know is what n is, and I only need to know the first and the last term. So if you look at part A here, S sub 15 for 25 plus 12 plus negative 1 plus negative 14 and so on. The common difference is negative 13. So the 15th term is going to be 25 plus 15 minus 1 times negative 13, which is negative 157. So the sum of those terms is going to be 15, the number of terms, times the average of the first and the last. 25 plus negative 157 divided by 2, which is 15 times negative 66, or negative 990. That's it. If it's written in summation form, remember we're going from 1 to 12, and it's 3 plus 4k. All right, so let's find the first term. Plug in 1. 1 times 4 is 4, plus 3 is 7. Plug in 12. 4 times 12 is 48, plus 3 is 51. So we're looking for the sum. It's going to be 12 times 7 plus 51 divided by 2, or 348. So let's go back to the notes, and I'm going to scroll down until we have a blank page here. Got some preview, some stuff you're going to see, maybe, and let's do this. So we had S sub 16 for 12 plus 7 plus 2 plus negative 3. So let's try that one first. S sub 16 for 12 plus, I've already forgotten what it was, 12 plus 7 plus 2 plus negative 3. So D is 7 minus 12, that is negative 5, right? 7 minus 12 is negative 5. A1 is 12, and n is 16, so I'm going to use A1 equals, or A sub 16 is A1 plus 16 minus 1 times negative 5, so that would be 12 plus 15 times negative 5. A sub 16 is negative 63. So the sum is going to be n times A1 plus A16 divided by 2. So that's going to be 16 times 12 plus negative 63 divided by 2. 12 plus negative 63 is negative 51 divided by 2 is negative 25.5 times 16 gives us, I divided by 16. Negative 152. Let me double check my math. 12 plus negative 63 is negative 51. Divided by 2 is negative 25.5 times 16 is, yeah, it's not negative 152. Whoops. It is negative 408. Now, if it's in summation form, which I believe you saw another example of, like this one here, from 1 to 15, 50 minus 20k. So 50 minus 20k, and we're going from k equals 1 to 15. Really doesn't matter, but I want to make sure it's right. Okay, so I'm going to find A1. 50 minus 20 times 1 is 30. A15, 50 minus 20 times 15, that's going to be a small number. 50 minus 20 times 15 is negative 250. So the sum of these guys is going to be 15 times 30 plus negative 250 divided by 2. So negative 250 plus 30 is negative 220 divided by 2 is negative 210 times 15 is negative 1,650. So that's that. I think that's about it. Oh, there is a story problem application here. The number of seats in the first 14 rows of the center orchestra aisle of the Marquis Theater on Broadway in New York City. Form an arithmetic sequence. So, how many seats are in the 14th row? So we have to figure out what the pattern is here. You notice, if you count them up, there are 11 seats in the first row. So the difference is 1. They're just adding 1 seat every time. So it's going to be in the 14th row would be 11 plus 14 minus 1 times 1. 11 plus 13, 24. So there would be 24 seats in the 14th row. If we wanted to find the sum of all the seats, rows 1 through 14, so row 1 had 11, row 24 had 24, so 14 times 11 plus 24 divided by 2 is a total of 245 seats. So that's it. Your homework is in Schoology, and smash that like button if you learned something today, and I will see you in the next one.